Hey everybody. In class we've been working on solving lots of different types of problems using proportional relationships. And tonight we're just going to take a look at 3 examples that show a particular way to do this. And that's going to be by writing and solving a proportion. Number 1 says, a 12-ounce can of Coca-Cola has 39 grams of sugar. How much sugar is in a 20-ounce bottle of Coca-Cola? So one way we looked at solving this, right, is using a ratio table. So if we have ounces on top of the table and we have grams of sugar, I'll put grams on the bottom, right? We can start with 12 ounces gives us 39 grams, and we would try to work our way up to 20 ounces and try to find what is here, right? We can use like G to represent our missing value for grams. Now this is one way we could solve this problem, right? And we could divide or multiply 12 and 39 by the same number to try to get 12 up to 20, and then we'd figure out what 39 is. Another way we could do that is we could just rewrite this as a proportion. We have one ratio right here, and we have another ratio over here. And we know one of our properties of proportional relationships is that the ratio always has to be the same. Right? If I multiplied 12 and 39 by 2 and got 24 and 78, right? Even though these numbers are bigger, the ratio is still the same. So what we could do is write that expression out. 12 over 39, that's the ratio of ounces to grams of sugar, is equal to 20 ounces over G grams of sugar. Right? The ratio here has to be equal between these two different amounts. Now notice, this is very important. On top here, these numbers, 12 and 20, represent the same thing. This is the ounces of soda. And on the bottom, 39 and G represent the same thing, and that's grams of sugar. Now, we can solve this proportion by finding what we call the cross product. So one way we can do that is we do 12, the numerator on this side of the proportion, times G, which is the denominator, and we get 12G. And on the other side, we have 20 times 39. 12G equals 780. And when we do the cross products with a proportion, they will always be equal. The numerator on this side times the denominator on this side will equal the numerator on this side times the denominator on this side. So we get 12G equals 780, and now we just have to solve. 12 times G equals 780, divide by 12. Divide by 12. And I get G equals, sorry, I had to grab my calculator, equals 65. So there are 65 grams of sugar in one 20-ounce bottle of Coca-Cola. All right, let's look at example 2. There are 287 calories in a 6-piece order of McDonald's Chicken McNuggets. How many calories are in a 20-piece order? So we can write our ratio of calories to pieces, 287 over 6, right? We have how many calories in the numerator, and we have the pieces of chicken in the denominator. Now, it doesn't matter where these go. We could have put the pieces of chicken on top and the calories in the denominator. The key when we're writing proportions is that we're consistent. Whatever we put on top on the left, we got to put on top on the right. So on the right now, I'm looking for the number of calories in this order. I don't know that. I do know that this order is going to be 20 pieces. So I'm going to put C as my variable in the numerator. And same thing here. We have calories on top and then the pieces in the order on the bottom. Now we're going to do the exact same thing we did in the last problem. We're going to find the cross product 287 times 20 gives us 5,740, and that's going to be equal to 6 times C. 6C. Now, this is just a simple one-step equation. You just have to divide by 6, and I get C equals 956.6 repeating. Now, we're talking about calories here, usually on the nutritional packaging, right? They don't really go into decimals. So we're going to round this one, and we were going to say that this order has about 957 calories for the 20-piece order. Alright, let's take a look at one last problem. Tammy drove 350 miles today on 20 gallons of gas. Tomorrow she has to drive 895 miles. How much gas will she need? So I know on my first day I have 350 miles and I have 20 gallons of gas. So I could write that ratio however I want. I could write 350 over 20 or 20 over 350. You know, since miles comes first in the problem, I'm going to put that on top, but we don't need to. 350 over 20 equals, now I got to be careful since I have miles on top right here, I got to make sure my miles goes on top over here too. We always want to be consistent. So that is going to be 895 miles, and I have 20 gallons of gas on the left. I got to put gallons of gas right here, but that's what I'm looking for. How much gas will she need? So I'm going to use a variable to represent that. Let's go with G. Now I can find the cross product. 350 times G, if we multiply the numerator by the denominator on the other side, and 20 times 895. That's going to give us 17,900. Now, simple one-step equation here. We are just going to divide by 350. Divide by 350, and we have G equals 51.1428571, and that's going to keep going. Okay. Now, we're talking about gallons of gas here. Usually, we're not going to be that precise when we're pumping gas. Since 51.14 etc. gallons is how much I need, I don't want to get under that. So I'm actually going to want to get a little bit more gas than that, and we can say we'll get 52 gallons of gas. 52 would be a lot better than 51. We don't want to run out of gas right before we get to our destination. So 52 gallons of gas to drive 895 miles. Alright, that's our last example for tonight. You guys can go ahead and finish up your notes, submit them through Canvas, and I will see you all in class tomorrow.